Good morning, students. Welcome back to the online lab sessions. So, in the previous lab class, we have seen some experiments, or rather, one experiment has been shown regarding and probably no, the experiments were not confirmedly shown. There was a discussion. So, in the previous class, probably I discussed about the syllabus, the different groups, the reagents, and of the groups, the cations basically, not the anions. So, the cationic ions classification, the group classification, the discussion, the reagents responsible, or rather, reagents which are associated with each individual group, that were all these things were discussed. So today we are going to perform some experiments. Today we are going to perform some experiments, and in this class we will be seeing that how the groups are analyzed. All right, how the groups are analyzed. So in the upcoming video, you'll find that two groups have been demonstrated. So group 0 and group 1. So the two groups have been demonstrated over there, considering some salts corresponding to that individual group. And if you remember, that group 0 corresponds to ammonium ion, and group 1 corresponds to lead ion, Pb2+. So these two ions demonstration have been done, and how the groups by what particular way the groups are identified, that has been shown, followed by there has been one confirmatory test also, which has been shown over there. So without wasting any more time, let's move on to the video straight away, where I will see the experiment. Okay.
So we'll carry out the experiments today. The two experiments are just let you know about the group, okay, group identification. I have taken, this is an ammonium salt, okay, this is an ammonium salt, as you can see, and what I'm going to do is, I'm going to add NaOH to that, okay, I'm going to add NaOH, I'm having NaOH with me, as you can see, this is NaOH solution, so I'm going to add NaOH solution to this, solution to this, and after that I will add, if I start heating this one, so ammonia gas will come out, a pungent smelling gas. But since this is basically a video class is going on, an audio session class or a video session class is going on, so pungent smelling gas will not be able to feel that one. For that reason, what I'm going to do is I'm going to show you a confirmatory test of ammonium ion. Okay, we all know that any ammonium salt reacts with bases or alkalis to give ammonia gas. So and you have read that one, that ammonia gas, when it reacts with Nessler's reagent, what is Nessler's reagent? K2HgI4. So when it reacts with Nessler's reagent, it turns the solution brown. So let's do it like this way. I'm going to just fix this one up. This is fixed. So the ammonia gas which forms, basically it will. So now I'm going to heat this. Okay, now I'm going to heat this. You can see this one. When the ammonia gas will be passed through Nessler's reagent, it will turn the solution brown. As you can see, the solution is turning brown. You can check it out. The solution is turning brown. I hope it's clear to you. So this gives a clear confirmation this is Nessler's reagent. And hence, confirmation about that ammonium ion is present. NH4 plus ion is present inside this solution. That's a confirmatory test. So this changeover from a transparent colorless solution to a brown solution, which you can see, This is basically about Nestle's reagent changing its color, and the confirmation is NH4 plus present. That's a confirmatory test. We move on to the first identification of groups. How we will form groups, or how to form groups, or how to start with the group analysis, that is, I'm going to take this one, basically. Let me go with this, that is, group 0 I've started. Maybe I'm not having a salt in front of you. Basically, what I've prepared is, okay, let me just show you up. This is basically, I've taken a group 1 iron salt, lead nitrate, salt solution. But, though I have taken a solution, I'm shifting to my over here and showing it to you. Though I have taken this salt solution, but you will be writing this one as salt plus distilled water. Salt plus distilled water is equal to OS. OS means original solution. OS means original solution. And all the experiment of ours will be based on this original solution, OS. So what is the method of preparation of original solution? Salt plus distilled water will give us the original solution. So this is my original solution. What I've taken right now, you can see this is my original solution. I've taken the salt, and to that I've taken, it's a lead salt, and I've taken to that distilled water, and this is my original solution. Now, as I've written over there, what's my first the reagent of group 1? I have to start accordingly. I have to start with group 0, followed by group 1, group 2, with group 3, and accordingly we will move on simultaneously, sequence-wise. The reagent of group 1 is dilute hydrochloric acid. This is the reagent of group 1. And if this lead ion is present, I am saying that I have taken lead salt. But how can I prove that this is lead salt? If lead salt is present, then definitely this acid, when I will pour this one, you will get some precipitates. The color of the precipitate has to be white. Let's check it out. You can see a white colored precipitate has formed. You can see dense white, a thick white precipitate. The moment I added hydrochloric acid, we have seen that I have taken hydrochloric acid, and I poured that one in the solution, and what you got is lead chloride, or a white precipitate. But this confirms that lead, it's not a confirmatory test, but will give us the information group 1 is present. So this confirms group 1 is present. This doesn't confirm lead is present. This confirms group 1 is present. So this is basically a dry test which confirms the group 1 is present, but for confirming lead, we have to perform other experiments. Those other experiments I'm going to show you in the next class. So till then, thank you so much. I'm going to stop over here for the next classes. Thank you.
So that's with the group identification, and we have seen that how the group identification goes. Followed by with the group identification, that's what's basically done with group 1 cation you have seen. If you move on to the reactions which are involved with the group 1 identification, rather cation, or the group 0 rather. So the first it was group 0, so we took ammonium salt, as you can see, NH4Cl, and we added NaOH, that's an alkyl urea base, and the reaction is salt plus water plus ammonia will come out. So ammonia gas evolution, it's taking place, and if you see there's a reaction, Nestle's reagent, K2HGI4. This formula you are very much familiar with in class 10, if you remember, chapter ammonia. So this formula was given over there, Nestle's reagent. Nestle's reagent, along with that, when ammonia reacts, it forms this particular compound, Hg2O.NH2 and bracket I. So this particular compound is basically brown precipitate. This particular compound, Hg2O.NH2, this is basically the brown precipitate. Now, Along with this precipitate, it forms potassium iodide and water. That's basically a transparent solution, so will not be interested in that. So this formation of brown precipitate confirms that ammonia is there. Another thing is we have said that this is Nestle's region K2HI4, but you may be getting confused, or you might get confused to why in the previous reaction we added NaOH. Over here we are adding KOH, but the reaction is basically with ammonia and K2HI4. Then what's the purpose of this KOH? Now to answer this question, what the purpose of this KOH is, Nestle's reagent is actually, this alkaline solution of potassium tetraiodmercury 2. This is it's an alkaline solution of potassium tetraiodmercury 2. So it's a mercury with a valence, it's a mercuric compound. So this is Nestle's reagent, alkaline solution. For that reason, KOH is there. Okay. For that reason, KOH is there. So it's an alkaline solution. So K2HI4 is fine. So, but since it's an alkaline solution, so KOH is already there in the medium. So within that, ammonia is passed, and finally this reaction takes place. And we took about we took lead salt. Along with that, we had HCl and formed a white precipitate of lead chloride and nitric acid. So lead chloride separates out from there, forming forming a white precipitate from and it separates it from the reaction mixture, and along with the dilute nitric acid is formed. So these two products. So this signifies or gives us the information that group 1 is present. If a white precipitate is forming, it signifies that group 1 is present. Regarding the confirmatory test, so previous one with ammonia, as we already did the confirmatory test. With ammonia, that's group 0, we already did the confirmatory test, that is with the Nestle's reagent. So that's a that's a clear indication of ammonia, and it's a confirmatory test. That means ammonium ion is present as well. NH4 plus ion is present. With that confirmatory test, NH4 plus ion is present. But along with, if you're focusing on this lead, basically, then this lead we have already done the group identification. Confirmatory test we haven't done. So in the following classes, we're definitely going to perform the confirmatory test of lead. So there are a few steps involved with the confirmatory test, how it's done. So that will be discussed later on in the next upcoming classes. So till then, thank you so much, and stay safe and take a very good care of yourself. Thank you.